We in data warehouses, we focus more on modeling and analysis of the data, which is readily useful for the decision makers to take a decision. So the main focus is we are doing the analysis. Modeling you do only for the analysis perspective. Then it also gives a very simple view, concise view on a particular subject issue by discarding unnecessary information. Only we take the relevant data and then we organize the data over the subject headings. For example, here if you observe here, this table says there is one subject called sales subject. For sales subject, there can be different types of sales systems may be there in different sources, in different formats. One may be a retail sales system, there can be an outlet sales system, there can be a catalog sales system, etc. But all these different types of sales systems are pulled up together under one subject heading. What are my sales? So sales is my subject area. So subject oriented sales information is combined, pulled up together in the form of a central repository on a subject called sales subject. So therefore, data is categorized and stored based on the business subject rather than by application. For example, if you take any banking system, in banking we have different types of accounts: savings account, shares account, insurance account, loan accounts, equity plans accounts. So many schemes and accounts will be there. Now all these things we are combining and then mapping into a single subject called customer sales subject, customer financial information. What is the wealth of the customer? To know the wealth of the customer, I would like to know what are his commitments, what are your loans, what are your accounts, what is the salary. All these things are taken. So therefore, the data is organized on a customer financial information as a single subject by pooling the data from different applications. Sales is one application, savings is another application. So from all these things, data is pulled up and then stored one for each customer, all the commitments, right? So that's why it's called subject oriented. Then second one. So these are all different subject areas: business customer area, customer account, product sales, customer savings, telephone call usage, passenger booking, insurance claims. These are all different subject areas depending on the nature of the application. So therefore, modeling is always contains measures and analysis criteria. What you want to do? Suppose I want to identify who are my potential customers to be considered for providing gift vouchers, so that I can attract better customers, so that I can get more business here. How do we identify? So for that purpose, we do the analysis based on the modeling. Okay. So more detailed example. Subject oriented is moved into process oriented. Subject oriented, both are given here. See in the process oriented, we put all the data in one structure. But now we divide this into three parts: sales subject in one group, customer subject one group, product subject one group. So this is called subject oriented, right? So therefore, then the second point, integrated. Data warehouse is subject oriented. Second one is integrated. Integrated means all the data is pulled together at one place. So there can be some internal data, there can be some external data, and then all the data are combined, placed at the central place, which we call as a integrated. And then that integrated data is readily available to create your own reports, your own graphs, your own charts, your own histograms. So for analysis. So that is called integrated. So what is integrated here? Application flavor is not taken into consideration while integrating. subject flavor is taken into consideration while integrating. So here in the normal databases, we write different kinds of code for each application efficiently to run my database application. But now in data warehousing, all these things are collapsed and grouped together into a single subject called customer. Accounts data, savings data, loan data related to all customers are combined and stored in one repository. That's called integrated. For example, you can spend some time here. So in one application, sex is declared as MRF. In another application, sex is defined as 1 or 0. In another application, sex is defined as X or Y. So when you are defining, when you are encoding, when you are integrating, I can't put the different data item values on sex. Everything should be grouped. That means a lot of transformation needs to be done. That's why in ETL we do extract, transform, load. So all the three applications data which are stored in a different way, they're all combined into a single way called male and female MRF. Similarly, in some applications, we have a pipeline is measured in centimeters, somewhere it is in MCF, somewhere in inches. Then everything we can move it to pipeline. That means some transformation we are doing in that while cleaning. So everything is unified into a single framework. That is called as a integrated. Right? So while integrating, there is a convention, there are some standards, we have to follow certain measures, and then uniform naming of attributes is required, and a lot of transformations are required, and all this cleaning we have to do in order to resolve the inconsistencies, and then, but this process takes more time and it requires commitment, right? So these are all ultimately integration, ultimately builds a single set of consistent, accurate, and quality information. Consistent, accurate, and quality information. While doing this integration, lots of problems may come. Somebody may write address Mumbai, somebody may write Bombay, somebody may write something else. So Chhatrapati Shivaji terminal, something they write. So how do we keep everything together into a single naming framework? So a lot of integrity problems are going to come. So all these things needs to be resolved, and then unified manner you have to build, and then properly you have to resolve the inconsistency problems, and then make the data consistent. So this is called integrated. Then, for example, here the next one is time variant. Time variant means data stored in a series of time snapshots, each representing a period of time. Suppose if you take a sales data, January data at the end of the month, I will put summaries of all January sales data. That means 31 days you do a lot of transactions, but we never do anything. We consolidate and then put summaries of the January sales data in one record. Similarly, February, as and when the February is over, February data, March data, etc. So they store in the form of snapshots. So time variant means data is stored as a series of snapshots. So historical data, nobody can change it. Once the sales data is over, once the sales are over, I can't update my sales data. I can only consolidate, I can only analyze, because it's the history. We can do the forecasting, we can do the trend analysis, right? You can ask any question on the data. So time is always must. That's why it's called time variant. Sometimes time attribute may be there explicitly, or maybe implicitly, maybe derived also. So therefore, at what interval you want to refresh the data, update the data, bulk update, and how much frequency you are doing, and at what level you are storing the data. All these things are part of time variant. So grain may not be same as the refreshing frequency. Grain is to be determined is a level like our grain size is small. We can put more data is required. If grain is large, less data will be there, less rows will be there. So higher the grain, lowers the data, lowers the grain, higher the data. So always there is a trade-off exists between the grain versus the summaries. So this is called time variant. So in the transactional database, user always do what is my data, what is the committed. But whereas in historical data, we prepare the sales over region wise, year wise, monthly wise, etc. That's why this is called historical data. Then time can be past or current, and time element is compulsorily there, right? So for example, this is the data, sales data, year wise, 2006, 7, 8, 9, 10, etc. Like this you can put it. Then comes non-volatile, last one, integrated, time orient, subject oriented, then non-volatile. Non-volatile means what? Data in a data warehouse is not updated or deleted. History nobody can delete it. Once history has happened, that history will be there permanently. So therefore, only reading the operation only we do from the data warehouse. All the remaining operations, insert, delete, update, we always do day to day, every day on operational databases. But in the warehouse, once the data is consolidated, we once load the data, only operation we do is reading. Loading and reading are only performed on the data warehouses. So this is an example for non-volatile data. Non-volatile data load and access are there. There are no manipulation operations. So data warehouse is physically a separate store of data transformed from the application data found in the operational. That means whatever the data is available in the different operational databases, all the data is modified, changed, which we call as a transformed, and then pushed into the warehouse, which we call as a loading. Once the data is loaded in the warehouse, we only read, we only do some analysis. We don't change the data values. That's called non-volatile. So therefore, there is no transactions exist, no failures. Even if some failure has occurred, we can recover by doing the process again. And many people can access simultaneously. There is no problem because updates are not happening. Only everybody is reading and then doing the analysis. Therefore, more analytical users can perform the analysis simultaneously. Only operations required in a data warehouse are only loading the data and accessing of the data. So for example, in the OLTP, we do reading and writing. Whenever somebody withdraws some money, immediately the operation is committed and then your bank balance is updated. But in the once last year account statement, last month account statement, if you take already whatever committed transactions are committed, you are only reading. You are not going to change anything because history is already created. So therefore, the data warehouse size changes over a period of time. Historical history of the institution, history of the data in your MIS also will change over a period of time. Then when batches are goes out, your data size increases. That's why we do a lot of backup, purging, archival, everything we do. Right, I will give here a break to take some questions. Then I will continue. Yeah, questions please. Yeah. Any questions? Hello?
No, sir.
So what is a data warehouse? Who will tell what is the definition of data warehouse? How do you define a data warehouse? See, if there are no questions, there are
Process
only two things.
process of
Yeah.
converting data into information.
Yeah. What are the different qualities required to become a data warehouse? What are the different qualities required to consider that as a data warehouse? I told 4 points,
Timely,
right?
the information should be timely.
Time variant, not time,
Time,
time variant,
yeah, time.
integrated, subject oriented,
Integrated,
and
non-volatile.
non-volatile.
Non-volatile time variant.
Non-volatile collection of data in support of making decisions. Ultimately, for decision purposes, we have to use, right? So,
Yes, sir.
subjects means broadly we are putting the data, transforming you are doing, and then you are combining the data from different sources. That's integrated, and then data gets updated at very infrequently. That's why it is non-volatile. Okay, integrated, non-volatile, time variant, and then non-volatile data in a data warehouse stays for a longer time, whereas data in a database gets updated very quickly. See, whenever you are booking a ticket, once you get a confirmation, number of berths available in that train for that book for that coach gets reduced. When simultaneously different people are performing reservations, all are having the impression that my ticket is booking first. But everyone gets different berth. How it is happening? Because it is an online transactions, right? So data in a database changes very frequently, but data in a data warehouse changes very infrequently. That's why it's called time variant, non-volatile collection of data, right? Clear?
yes, sir. Clear.
Okay. So this is about the data warehousing. See, normal databases are different, data warehouses are different. So let me continue. Yeah. So what are the benefits? These are all self-explanatory because you can. The one of the advantages we are going to get a access a wide variety of data. Wide variety is large. It's a huge repository of data. It's a wide variety, and results can be presented in different formats the way you want. But whereas this was not the case in the case of file in the databases. In databases, everything is predefined. You cannot change the format in between. But whereas here, whatever graph you want, whatever report you want, you can generate and then run the data, run the query, and then get the result. Right? Enhances the value of operational business applications. So your business decision making is changing. And cost of production comes down with the target marketing campaigns. So you, by putting more market campaigns, more benefits, etc., your product introduction of the product gets reduced, and you are taking better decisions at low cost, and you have a clear picture of asset and liability management. How you are managing your warehouses, how much, how people are buying, what are the different purchase patterns, what are the different inventory patterns, all those things you can extract. And of course, ultimately, customer is the king. You are maintaining good rapport with customer by understanding their requirement. By seeing this, you do some market basket analysis, and then we get some clues. What are the interests of the customer? Okay, these are all some of the benefits. But limitations are also there. We cannot add additional data, additional type of data once the warehouse is built. But quality of the data is poor, then decision making is inaccurate. That's why high quality data is important, right? So, of course, risks are also there. Some risks are organizational risks. Your project team leaves in between of the project, then gone. It's an organizational risk. Technology is not properly chosen, and If your size of the data is large, and if your systems are not supporting, then your architecture is wrong. Then your scalability is wrong. Then it is a technological risk. Then your project's scope should be well defined with the right cost. Otherwise, it is going to be a dead project. And design, if you're not properly designed, if you collect only poor data, unreliable data, improper collection of data happens, then it is a risk of the data warehouse. So therefore, risks are there, investment is more, but the advantage is there, but people should do with commitment. Right? So why separate? Why do we separate? So far, no participant has asked. In fact, these questions I have devised by taking the feedback and questionnaire from my 2006 passed out students in NIT Warangal. Then I prepared the slide to explain to them in my presentation. So why do we separate data warehouses? Why can't we make everything database, data warehouse as same? Because in order to get performance good in both the situations, operational systems, operational databases are designed and tuned to execute the transactions efficiently and to manage the workload of the transactions. And complex query processing, whenever you perform a very big data table access, and if you do a lot of calculations, then your memory time, system time, your CPU time is taken care by you. So in the process, a small work has to wait for a long time. Therefore, your operational systems reduces their performances. Then customers will get dissatisfaction. That's why complex queries always degrade the performance in the case of if you combine both. That's why we are separating. Then special organization, special structures, special implementation methods are required to perform, to view the data for different purposes in different angles with different designs. So that's why in order to overcome these difficulties, we are separating the warehouses with the databases. Then, functioning point of view, missing data, we need to, missing data always be there in the normal databases. We have to fill the missing data. So data consolidation is also required. Decision support requires integration, consolidation, based on the grain size. And quality is important. Quality of the data is important. Then applications point of view, you have to decide at what level you are going to store the data in a data warehouse. Do you want to store the sales data monthly wise, day wise, or hourly wise, or minute wise? If you store data minute wise transactions, your size will increase. Then you should have capacity. You should have scalability issues, right? So all these things needs to be considered for before building the data warehouse, right? So therefore, from the usage point of view, data warehouses provides a good presentation reports and graphs, which normal databases won't give. And for multi-dimensional analysis, we use data warehousing. And also to discover the knowledge. To discover the knowledge, we use data mining. So for data mining applications, for multi-dimensional analysis, we use data warehouses. Right? So what are the advantages? We are minimizing the cost of accessing. We are improving the response to the customers. We are identifying the hidden business opportunities, golden nuggets, right? Using mining here, whatever your knowledge is hidden in the data warehouse, everything you are digging out. And then ultimately you are making a strategic decision making in the interest of your organization. So data warehouses are also of three kinds. Sometimes we known as simple data warehouses are called operational data warehouses. And if you build a data warehouse for complete organization or your enterprise, it is known as enterprise data warehouse. And sometimes you may create a small subject specific data warehouse, which we call as a data mart. So these are all different types of data warehouses. And but all these things are basically when we do the investment, we should also think when can I expect my revenue? When I am spending crores of rupees, ultimately at the end, if I am not getting any business out of it, it is we are putting in the sea only the money. Therefore, the customers better market enhances a better market for customers by building the data warehouse we can do, but it depends on how rapidly accessing the data, what are the different types of reports you are accessing, and whether you have flexibility is given while preparing the data or not. They all need to be taken into consideration at the time of investment, right? So return of investment always depends on the various times, and then risk also needs to be assessed. So therefore, when you actually data warehouses are basically meant for executives, managers, and business analysts. I am putting right side different systems, left side one system, analysts. In between, you are doing so much work. For what purpose? To know how my business is doing. So to do that, we do all these things. So we do all these things process. This entire process which is given in the middle level is known as the data warehouse. Okay. So this is what the data warehouse means. Right. So to conclude, here I talked about importance of databases, file systems, and then why do we require data warehouses? Then what is data warehouse? Then how data warehouses changes your business strategy, etc. So with this, I completed the first subtopic of the importance definition of the data warehouses and main databases. Then tomorrow, how many of you have registered for SQL course? So OLAP, what is OLAP means? Online Analytical Processing. This we will discuss now. Next topic is this only. Online Analytical Processing. That means how to perform, how to do the analysis on the warehouse to get my quick results. Managers, say, ultimately managers have to do, managers always think data in a different perspective. High level executives think data in some other perspective. Low level people sees the data in some other perspective. So depending on the level of the manager, we have to decide the analysis type. So that analysis we do by using online analytical processing. That I will discuss in the next class. This topic will be discussed in the next class. Next class is on OLAP only. Okay. So any questions?
Okay, sir. No, sir.
It's clear?
Yes, sir.
So now, tomorrow, of course, Sunday, there is no class. Okay. But I don't mind taking class if you are willing to come. Okay. Otherwise, we will meet Monday. Monday, I will take OLAP. Okay. So OLAP is again a different kinds of a ball game which works on top of data warehouse. All of you please read some fundamental. I am not asking you to go through complete theory of data warehousing. It is a one semester course, but we will cover only 2-3 hours on data warehouse. So please read and brush up. And if you have any doubts, we will discuss further. Thank you. Thank you all. Thank you. Monday we'll meet.
Thank you, sir. Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.